So active-active implementations, we kind of hit on this a little bit earlier. But when you do active-active side of things and you're doing hybrids, you're kind of trying to make sure all your IOPS are done correctly. You've got multiple tiers. It's a hard problem to end up solving. And trying to get our test coverage on an active-active system, you heard us talk a little earlier, kind of the VSA style of things where we actually can run in a virtual environment. We can run virtual active-active environments. That helps us with some of our functionality on getting the test coverage and getting the clarity and getting the depth of functionality, but we also have some functionality with, we actually call, I'll let Patterson talk a little bit about this. We call it our sheep functionality, but they go out and test our N5s. We set them up, run them in a lab. It's electric sheep, and so they beat up the active-active boxes. They run through reboot cycles and failures and kills and all kinds of stuff that would be very difficult for us to do manually, but we've automated to improve the active-active functionality and test that feature and functionality. And so Patterson does a lot of the CLI for us, which is the second bullet down there, and he's actually helped us with leveraging and setting up the electric sheep. So I'll let him talk a little bit about the CLI, which is our other management interface that's coming out. As you all know, in most environments, people want to be able to program things and script them and run them from outside. Exactly, exactly, right? We picked for a reason. It's given us a little bit of troubles here and there where we've had to do some things, but not that big a deal, really. It's been a really good interface.
Yeah.
And the CLI is rolling out, so.
Before you go on to the CLI, can we just clarify active-active? Because as you know, a lot of people
Sure.
say active-active
active
and really mean
Right.
dual active. So is this really peer-to-peer, no preferred paths, total ownership of every resource?
We have login redirect right now, so we're kind of active. There's kind of an ownership concept.
Okay, so it's dual active.
Well, right. The next release that's pushing out the door right now is actually active-active. We'll do a Lua.
Okay.
So then any I/O can come in anywhere. So we knew that at day one. We actually had a lot of that coded to our test infrastructure, test time. We chose to kind of hold that back until we could get more.
Use your product.
Well, exactly. I mean, customers are saying, "Hey,
Wait,
you
do
know,
you mean me or?
yeah, Spires. We got to use Spires."
The tall guy who, yeah.
He's tall.
The tall John. Yeah, you're better than that.
I'm really.
The other tall John.
I know you.
We'll get to the sheep, but
It's
this,
the electric sheep.
it is.
And there's one right behind you.
This is a sound that drives fear into engineering's heart because when the test robots, that was a fake defect, just so you know, it didn't really happen. But when that sound comes across, it means we found something
Yeah.
of interest.
Yeah, our sheep, we do have them tied in like that, and you can actually hear them down the hallway when things start going on. So you'll hear people. You'll even hear, John Spires, tall guy, comes out of his office and says, "What the heck? What just happened to sheep?" Right? So when we're-
Sometimes we set it off just to wind them up a
yeah,
little bit.
just to get people out of their offices and chatting about things. So it's fun. It's fun. It's a good tool. It's a lot of fun, but it's really given us a lot of clarity. I'll let Patterson
Sure.
talk some about it. There again, see, I use Patterson because
Yeah. Yeah. So I was thinking this morning at 4 o'clock when I couldn't sleep how I was going to make test automation interesting because it's like talking about apple pie. Everyone gets that that's an important thing to do. I was reading a local newspaper article and there's a quote from one of our investors, Kirk Holland, who said, "What this team did, they did a phenomenal job of being very capital efficient as they built the business. The company only raised $12 million. That's a very, very efficient use of capital." That's the venture capital perspective of what we did. The engineering perspective is sort of, holy crap, you mean I can't hire any testers, I can't buy more hardware, I can't buy servers, I get no more lab space. And we still have to make this thing work. So my initial role here was to do some application integration work in Windows and other things, VMware. But my job was sort of re-architected pretty quickly to try to fill that testing gap. And the challenge was multifaceted because we had a pretty small test team compared to our development team that was racing really quickly. And by small, I'm just going to say 2 people when I got here, so very small. And the best in the world at what they do, but that's just not enough. And they have to sleep at night, so they go home and we have all that rack space just sort of sitting idle. So we had to develop something fairly quickly to get the coverage that we need. And also, as we alluded to, in an HA system, we hope to be active and both sides up and everything nominal as much of the time as possible. But the code paths that you really need to exercise are the hard ones, the ones during failover. So it really is for us all about fault injection. We built a CLI. One goal with a CLI is that you really want those sets to be completely overlapping. So there shouldn't be anything a CLI can do that's magic that the UI can't do, and vice versa. It should be a complete coverage, so that when you build this automation, you're truly testing the system. UI testing is not one of the goals of this. That's notoriously hard and brittle. But one way to solve that is you make your UI as thin as possible. You use REST, and you make that, not have any business logic in it. Make it small. So that's what we did. We built out a pretty extensive test automation scheme using Python. We examined a bunch of test frameworks that were already out there to see if there was something we could leverage. They tend to be very good at syntactic analysis and kind of light static analysis. You throw something out and you expect a certain return. But in order to do the deep kind of fault injection analysis that we wanted to do, we thought Python was a pretty good choice for us. It's multi-platform and it has lots and lots of rich libraries that we could leverage to get the job done. So what informed what we built from a test automation standpoint was really two things. One is, what do we want to test that doesn't get tested in the field, hopefully very often, like failover. But also, what can we... Sorry about that.
I'll have to inject here. Patterson's phone is no longer allowed at his house.
That is true. It was funny the first time, and at 3 o'clock in the morning, both the phone and I were banished to the couch. So yeah.
Not surprised.
Yeah. So the sort of the secondary goal of the test automation is observe what the team is doing and try to help them out. So watch what development is building and know that what they're building that's new is going to be something that really is deserving of lots of tests. But also observe the test team and find out what they're doing in a manual sense that just is inefficient for them. So as an example, with an HA system, if you have on a host, you have a couple of NICs and you have 2 controller halves, each volume that you provision is 4 connections you have to set up. So you provision 25 volumes to do some scalability testing. That's 100 connections that people were doing sort of manually, instead of just pushing a button and getting it done correctly and automatically. It would also kind of tend to have people behave badly because they create test systems and then jealously guard them because they were so hard to set up that people were reticent to move to the next version of software. So that was kind of another goal of automation, just to help the team out. So anyway, I won't belabor this. I know it's a lot of apple pie, but I think in our case it was just particularly important given the accelerated development that we had and the constrained finances that we had, frankly, that test automation was multiplicative in its efforts to help us root out some really, really nasty problems that are rare.
How confident are you that your test regimen was able to, identify and sort of move your product forward?
Well, I mean, you can certainly go back and look at our bug database, and we would flag those things that were caught by test automation, so we know what the value of that was. If you're asking me how confident am I that the system is perfect now,
I would never ask.
actually somebody asked me the other day, when are you going to be done with this electric sheep thing? And the answer was never. We're never going to be done. It's something that's always going to evolve and hopefully be really, really far out in front of our customers. That's the goal, that we want to inject so much vault and run this thing into the ground. The goal of the electric sheep is to break the system. And we try to do that every single day, and we're really happy when we don't succeed. And when we have 24-hour runs where this hasn't happened, what that means to us is we've had 50 to 100 failbacks by various means. I mean, we'll yank power on one controller, we'll pull disk drives, we'll do nefarious, evil things to the system.
Create and delete thousands of volumes and move them between policies
And when that all
things.
passes,
Yeah.
John goes up and finds another evil thing.
Yeah, I know. He gets creative.
Yeah, so there are lots of different flavors of the sheep. Since we're being filmed, I can't tell you all of them. but there are performance sheep. There's code coverage sheep. Evil sheep.
Evil sheep.
We also do some interesting. Seb's working on some interesting.
The concept of evil sheep.
Evil sheep are evil.
Yeah.
They are truly evil. Lots and lots of threads doing as much simultaneous work as possible to create snapshots, delete them, move policies, extend volumes. Lots of
And
evilness.
fail over all at the same
And
time.
fail over and and see if the system stays up. And it's remarkable the progress we've made with that.
And something else we use it for, if we discover a problem not with sheep, before
find a problem with the
build.
product
Yeah.
Right.
without the sheep, then we build a test case with the sheep
Yeah.
to specifically test for that, to make sure we never regress the code and break it again.
And that's either in the field or in-house. And another interesting point there is that you have to decide what your input is going to be to a test matrix like this. Like, how many volumes are we going to create? What size are we going to create? What's our block size? What's our I/O profile? What's the pattern of the data? How big are the blocks, et cetera? We probably have 40 to 50 of those input parameters. Well, what happens is you build this test and you start finding lots of interesting things, and people tend to kind of fixate on that input profile, right? It's sort of like you're mining for gold and you found a little vein of gold and you stick with that. Problem with people is they're not very imaginative, and they might be missing something bigger in another area. So what we do with a lot of the input to the test is we build pseudo-randomness into the input. So there's a range of things that the test might choose, and that pseudo-random choice is seeded with something, and we go off and choose a profile within those ranges. And then the interesting question is, how do you choose those ranges? Well, we look at customer data from support logs to the extent that they opt in and they want to ship that back, and we know kind of what they're doing with an approximation of the control path, certainly none of the data. We know how many volumes might be appropriate to choose. So we'll choose a range for our customers and maybe stretch that out when we know that we're going to be scaling in the next release. And that's the choice for input. Somewhere in that range, pseudo-randomly, choose a profile. And we find things that we just weren't looking for.
Sheep are fun to talk about. I know we're kind of running out of time. I wanted Patterson to talk quickly about the vCenter plugin if we
Oh,
can.
yeah.
Right.
Yeah, I know. Yeah.
I could go on and on.
That's how marketing thinks the electric sheep works.
Yes.
Oh, really?
I'll point out also that marketing slipped in the application integration slide on me and didn't give me any additional time. So they doubled my workload and gave me no extra schedule to accomplish that.
And you're surprised.
That's also how marketing
Welcome to
works. Yeah. Yeah.
Good work, Chris.
So, is vCenter plugin up there?
I didn't see a slide on it.
No.
Talk to
Okay,
just
so,
talk some questions about video integration.
I don't know if they've seen it or we've demoed it or we were set up to do that, but one of the application integration points that we have, obviously this is the storage array is targeted towards high integration, which means virtualization. We do that here as well. We have limited resources, limited lab space, so we also believe in that heavily, more apple pie. But we have a Virtual Center plugin that really gives the administrator the view into vCenter, and then we take care of the storage details behind that. So as an example, if you want to provision a data store, that's the terminology you use. So you would provision a data store, and we will go out on the array, create the volume, mask it back to the host, do all the connection, format VMS 5, 3, whatever size you choose, and put it in a policy that you've designated on the plugin dialog. So it's all soup to nuts, and rescan the bus, and there's your data store, completely built for you on our storage array.
Would you do something like that, or do you have a roadmap to do something like that for Hyper-V?
Sure. Yeah, I mean, again, Windows guy over here. So.
Apparently it's a thing with John.
Just say sure.
I see.
I say go see your manager and schedule it.
Center of the world. He's in Redmond.
Yeah,
I agree.
For John.
for John.
And
Yes.
John.
And John. For John.
Yeah.